George Washington Carver's enduring influence is evident in a diverse array of products that modern consumers use every day. Carpet backing, crayons, oil solvents, and even a new vodka are some of the items that can be traced to his experiments with another soil-enriching and protein-rich crop, the soybean.
We work in plastics, adhesives, in lubricants, so it's really a whole realm of new products from that technology.
Carver learned that the oil from soybeans is composed of 5 fatty acids, and that the bean itself is naturally rich in vitamin E.
You have a bean that has a lot of oil in it and a lot of protein, and it can be crushed and separated, and things can happen to that little bean.
When Carver looked at the soybean under the microscope, he saw that the oil had chemical properties that would allow it to easily bond with other substances.
The soybean oil itself is really long chained, just a lot of carbons in a row, 13, 16 carbons. And so that gives it ability to be a very flexible type of oil to be used, and it's also relatively inexpensive as an oil.
Carver's early experiments resulted in food products. Soy mayonnaise was one of his first successes.
He said he started work with the soybean around 1903, and by the time they'd finished that phase of the work, they had about 30 products.
When I go in a supermarket and go along the shelf of health foods, and you see bacon and lunch meat and the mock chicken and all those products that are made out of soy and other vegetable-based products, you just have to think of Carver. I mean, that was a major focus for him.
In his humble lab at Tuskegee, George Washington Carver experimented with a handful of beans, a coffee grinder, and some beakers, and came up with more than 100 new uses for soybeans and soybean oil, including a type of soy plastic. In the 1930s, automotive pioneer Henry Ford became aware of Carver's pioneering research with soybeans. In 1937, he invited him to participate in a scientific conference in Dearborn, Michigan. Ford shared Carver's passion for developing new uses for farm products, and he was a major player in the Chemergy movement.
And he was really taken by the fact that Carver could take soybean, for example, and come up with components of car parts.
You look at a guy like Henry Ford, who had tremendous resources, and he was always looking for the newest and the brightest and looking for other opportunities, and he saw this man Carver, and he saw him as just a gold mine, a wealth of information and a wealth of creativity, and really wanted to bring him into his organization. And Carver was not drawn by the money, not drawn by the opportunity. He knew that his job was to be there at Tuskegee, to teach, to guide.
Despite his devotion to Tuskegee, Carver continued to personally consult with Ford about his ongoing research in soy plastics. In 1942, the automaker unveiled a car that included a bushel of soy in its construction.
The gear shift knob, the door crank handles, the foot pedals, things like that. Mr. Ford had nearly 7,000 acres of soybeans grown right there in that area. He had the research labs right there that he worked in, and he tied that with industry in his plant of building automobiles.
In a rare film from 1943, the Ford Motor Company revealed a car that had some body parts constructed from soy plastic. Ford researchers wanted to demonstrate just how strong and ding-proof this material could be. And Henry Ford himself even took a few whacks.
Henry Ford took a mallet and hit the trunk lid of a Ford car to show the durability of soy plastic. We can do that today with soy plastic made from soybeans.
Carver and Ford's creative partnership is echoed in what the Ford Motor Company calls the U-Car. Built in 2003, this concept car's interior is made entirely from an eco-friendly recyclable polyester with soy-based seats and tailgate. While the Ford Motor Company carries on Carver's belief in the soybean's potential, so do scientists at Iowa State University, Carver's alma mater. But while Carver worked primarily with the oil from the soybean, they focused on soy flour. They've used the flour to develop a breakthrough formula for producing a new variety of durable plastic. Soybean farmers around the country are well aware of Carver's early research and the potential of using soybeans in commercial products.
George Washington Carver discovered years ago that there was this multitude of products that could come out of our natural bio products. Soy has been called the miracle bean because it is so usable in so many different ways. And Carver recognized that, and the soybean farmers of the United States have carried it that one step further.
The newspaper industry embraced the soybean in 1987, when soy ink was first used in the printing process. Today, more than 3,000 papers across the country use color inks made from soybeans. From the St. Louis Post-Dispatch to the LA Times, publishers are finding that the soy-based products are just as practical as their petroleum-based counterparts. Construction engineers are discovering the soybean's value as well. A recent example of their work is the new roof atop the Shed Aquarium in Chicago.
It's non-toxic, it's 100% waterproof. The application of it is very simple, very easy to do, and it will save us energy by reducing our heating and cooling costs in the building.
In the 1940s, the soybean's greatest champion had gained world renown as a scientific pioneer. But George Washington Carver remained a simple man. Although he was the head of the Agricultural College at Tuskegee, when he went out to the farms to teach, people often mistook him for a hired hand. But his trademark rumpled suit was never without some sort of fresh flower or weed in the lapel, a symbol of his love for nature.
Carver was a curious character. He cared nothing for his outer appearance. When he was going on speaking tours, if somebody said he ought to dress better, he would say, well, if they want a suit of clothes, I'll send them the clothes. If they want the information, I'll go.
Carver never married and professed to be completely fulfilled by his work.
Another thing he said about a wife was, what woman would want a husband forever dropping soil specimens all over her parlor? And how could I explain that I had to go out every morning at 4 a.m. to talk to flowers?
For nearly half a century, Carver lived alone in his room at Tuskegee. In his free time, he enjoyed crocheting, one of the handicrafts he learned back in Diamond Grove, Missouri when he was a child. Continuing another legacy from his childhood, Carver devised a way to make various pigments and paint from the soil he found in the Alabama countryside. He combined the clay soil with equal amounts of sulfuric and hydrochloric acids and bits of scrap iron. Carver then boiled the mixture until the iron dissolved. The result was a dry paste that could be combined with oil to make paint.
At that time, it was absolutely phenomenal. And to see the pure royal blues that he could extract from Alabama clay just is mind-boggling.
To achieve his brilliant blue color, Carver added a compound of potassium ferrocyanide and nitric acid.
See, the genius of Carver was that he wouldn't just do that and then write a paper and then get an award for doing that. He would then go out to people's farms and take these buckets of paint and stay overnight with the family, helping to paint and beautify their homes.
He was a chemist, a botanist, a biologist, an agronomist, and this consummate researcher. George Washington Carver was a man way before his time. Can you imagine what he could have done with a computer?
Carver was a fearless trailblazer, a driving force in discovering ways to use natural resources to benefit mankind. Another area of research he pioneered is just now starting to give the oil industry a run for its money.